Lesson 4 is angle property and triangles, and you probably know a lot of triangle stuff right now. And we're also going to look at those proofs again, where we justify something, we say something that doesn't rely on exact numbers. So pause the video for a second, list everything you know about triangles, and then come back and see how ours match up. So what I might write down here might not be everything that you know or written down, and that's fine, and we can add to the story as we go through. But in our previous lessons, we've looked at certain triangles, and one of them was isosceles. And isosceles triangles have two sides equal and two angles equal and two angles equal. We also know something about a right triangle. They have 190-degree angle, and usually you think of Pythagorean theorem when you think of a right triangle. So Pythagorean theorem only works for right triangles. A squared plus b squared equals c squared, and c is the hypotenuse. And finally, probably the other thing you noted, I mean, you could say acute triangle, obtuse triangle, all those sorts of things. But the other thing I think we all know is that the sum of interior angles of every triangle is 180 degrees. So it doesn't matter what kind of triangle, they all add up to 180 degrees. So using these ideas, let's prove something. Let's prove that last statement, that interior angles of a triangle always add up to 180 degrees. So you could label things however you want. Remember what a proof is. You have to have an idea of what you want to say. And here's what, let's make that an E. And here's really what we want to prove. We want to prove that angle B plus angle D plus angle E equals 180 degrees. And if we can prove that and give a reason, then we have no numbers and it doesn't matter. So first of all, we're going to use ABC. Angle A plus angle B plus angle C equals 180 degrees. And again, the reason for that is angles on a line. And we know that doesn't matter how you slice up a line, you're going to get 180 degrees. Now, based on our old stuff, you look at this right now and you go, okay, I have ABC equals 180 and BDE equals 180. Somewhere in there, we already have a matching up of a B here and a B here. And if we could get rid of the A and the C, then we would be the very statement at the bottom. So I hope you look at your little picture right now and see that, hey, we can get rid of the A because we know that angle A is equal to D. And we know that because they're alternate interior inside parallel lines on opposite sides. So those are equal because they are alternate interior angles. And again, what we now have is we go, oh, well, if angle A equals angle D, then there we go. I got 2 out of 3, and I hope you look at angle C and angle E and see the same thing. So angle C equals angle E, and again, same reason, alternate interior angles. And finally, given that we have that, where we have angle C and angle E, finally, we can plug in D for A, we can plug in E for A, and I'm going to say in plugging in mathematics, that's called substitution. So that's all I've done. I've used 2 properties that we know, and we have proved that it doesn't matter what the angles are, they will add up to 180 degrees. So here's a really poor picture. I was supposed to give you an exact picture, but I've just sketched it. So here's what we want to do. I want you to draw a picture like this, use a ruler, get your protractor out, and measure all the angles, and then see what you see. So pause the video, go ahead and do that, and then when you come back, my numbers might be a little bit different, and that's going to be really good because it's going to turn out that we're both going to see the same thing. So what I see when I measure, again, you have to imagine I'm doing this, but I have done it. angle A is equal to 130 degrees in my picture. Angle B is equal to 48 degrees. Again, I measured it. Angle C is equal to 58 degrees, and angle D is equal to 74. And again, if you look at your angles, they're probably going to be different, but something really interesting is going to pop out. So what I want you to notice is when you look at this thing right here, these three angles are related. And what you might notice on yours or what you might notice on mine is 132. 132 is equal to 58 plus 74. So this is not coincidental. It will always happen. And if you look at your relationship right now, you should see it's very, very, very close to that. Okay, so flip on the back of the page, and you're going to look at the figures below. And really all I want you to do is to have a look and go, okay, well, these are two stories that look very similar. We have an exterior angle, so the exterior angle means the outside angle. There it is there, and there it is right there. And we have an interior angle. Here it is here, and here it is here. And what we want to figure out is, can we figure out the two other angles? And in one of the stories we can, and in the other story we can't. So here, in the first example on the left-hand side, here we can figure out angle C. So can we figure out all the angles? So I'm going to call this little a, and I'm going to call this little c, and I'm going to call this little p, and I'm going to call that little q. And this one here, we can figure out angle C. So here, we can figure out angle C, which equals to 36 degrees, if we care, because of angles on a line, supplementary angles on a line. And then, given that we have that, then we can figure out, then we can determine angle A, because sum of the angles in a triangle. So that picture right there in the triangle, here's my little symbols in a triangle. So that picture there allows us to figure out, the angles in a triangle. Now, in the one to the right, we know, based on what we just saw on the previous page, we know angle P and angle Q equals 79 degrees. But we cannot know what they are individually, because we don't have the correct information. So we know that they add up to whatever and whatever, they add up to 79 degrees, but can't tell you exactly what they are. So over these last couple of examples, right, what you should recognize is there's this relationship between an exterior angle of a triangle and its non-adjacent interior, meaning not the non-adjacent means the one on the other side of the line. And the relationship is the exterior angle is equal to the sum of the non-adjacent, you might think opposite or whatever, the non-adjacent angles, interior angles. So that's a very nice little property. Angles. You don't have to do the work, you don't have to figure it out. Maybe it's enough just to know that, like on the top right example we just looked at, where we know what the two angles equal, but we just don't know. We don't know what, is it 40-39, is it 50-29, or whatever the case may be. So let's try to prove this. Let's try to prove that this angle right here is equal to the sum of the non-adjacent interior angles. So again, there's two big ideas here. We know that A plus B plus C equals 180. That's really important, right? And again, we're trying to generate something that makes sense. So let's start off with that. Now remember, always think about where you're going. So here's what we want to say. We want to say that angle E equals angle A plus angle B. That's what we want to say. And as I said, maybe a place to start off was angle A plus angle B plus angle C equals 180. And again, sum of interior angles of a triangle, right? Now, the other 180-degree thing we know is this thing right here. We know that those two things equal each other because they're supplementary angles. Now again, what I want you to recognize is they both equal 180 degrees. So given that, we can say angle A plus angle B plus angle C equals angle E plus angle C. And again, that's because they both equal 180 degrees. Now notice on each side of the equation, we have angle C. These are exactly the same. So if we took them away, we don't change the balance, we don't change the equality, and that's what we've just done. By eliminating angle C, we have just gone ahead and shown that we only have A and B on one side and E on the other side, and that is a proof. So again, proofs are one of the things we started looking at last day, and we'll keep looking at them a little bit. Okay, so now we're going to go ahead and actually I want you to measure all the exterior angles and determine any relationship. So we've been talking about exterior, interior, and right now we're just going to talk about the exterior. So here are the angles that I want you to look at. This angle here, this angle here, and this angle here. So exterior means outside. So again, pause the video, get out your protractor, and go ahead and measure those angles. So here's what I did when I measured. I found angle A is equal to 141. Angle B is equal to 116. Now these might not be perfect. I'm just when I did my picture, it wasn't exactly the same as this, so your numbers are definitely going to be different. It's difficult to work with this my computer with a ruler on it. So again, your angles are going to be different, but it's okay because we're going to see the same thing. So measure all your angles. Then what I want you to do is add them all up. So if you haven't done this already, all the angles aren't the same, so that's not a relationship. They're all bigger than 100, so we might say something about this. But here's what you should notice. And again, it's good that if I did an example, you did an example. We both get something pretty near the same answer. So this is not coincidental. This is a property of triangles. Just like the interior angles of a triangle always add up to 180, the exterior angles of every triangle always add to 360 degrees. So again, that's a really good thing to know, because what happens for you or what happens for us, we do not have to do all the work. We know a mathematical truth, and then we could just use that. So finally, just a kind of quick little triangle question to kind of bring everything together today. I just want to find angles ABC right now. And again, we can do them however we want. You might want to pause the video and try it. But I'm going to go ahead now. So in this example right here, here's what I know. I know that angle A, this whole angle, what I'm calling angle A in the 20 degrees, it is alternate interior to that angle right there, to 67. So here's what I know. I know angle A is going to be 47 degrees because angle A plus 20 is equal to 67. And again, the reason for that is they are alternate interior angles. So in this question, there's some angle stuff, there's some triangle stuff. So angle A is 47 degrees. Great. Now, I know something about angle B. Angle B is equal to 94 degrees. And the reason I know that is, now that I know angle A is 47 degrees, we can use the sum of interior angles of a triangle. Again, sum of interior angles of a triangle equal 180 degrees. So I add 47, I add 39, and the leftover from 180 is equal to 94. And again, that's important because that's the only way I can answer this question. So now I know A is 47, I know B now is 74, or 94, sorry. And then what I can then do is I can find angle C. And angle C is going to turn out to be 90 degrees, and the reason it's 90 degrees is it is co-interior with the bottom angle. So this whole angle right here, that whole angle is co-interior with that whole angle right there. So we know the angle at the very bottom, this angle right here, is 67 degrees. So if that angle is 67 degrees, that means the top whole angle, that can only be 180 minus 67, which is 113. And 113 minus 94 is 19.